take our quick look at our calendar here. We are in day 2 of 3 on these things called operations on algebraic fractions. So just a reminder, last class we introduced algebraic fractions. These are just normal fractions, but they include one or more variables, x's, y's, and z's, right? And we did 2 things last class. We learned how to simplify algebraic fractions. That is, just take a single fraction, look for some foo-foos that you can cancel. And then we also learned how to multiply or divide pairs of these algebraic fractions. And again, the key was to factor first, because the only way we can cancel things is if everything is multiplication. So today we talk about addition and subtraction. Last class was multiplication, division. And then coming up on Monday is our 3rd day on algebraic fractions. And on Monday, there's no demo. I'm going to demo the addition and subtraction stuff today, but Monday is just all activities. So pretty much today and Monday is just all about adding and subtracting algebraic fractions. It's harder than multiplying and dividing, which is why we're giving it some more time. And then after that, we got one last day, Wednesday, on equations, and then the quest a week from today. Questions on what's coming? Yeah, we have one more quest we're going to sneak in, then we have one review day on the last day of the semester, and then the final is on May 20. I agree. We lost 2 review days this semester from snow. Sorry. Other questions on the calendar? Okay. So let's jump up here to the top. I'll start with Marcy, the summary. Cody, number 1. Okay, so 2/3 plus 5/3, easy or hard? Easy, right? Because they have the same denominator. They have a common denominator. So when they have a common denominator, what happens to that denominator? Nothing. It gets copied, right? This 3 and that 3 make 3, not 6, not 9, not anything else, right? It's just copied as 3. Upstairs, the 2 and the 5 get added together. 2 plus 5 is 7. 7 over 3. Easy, right? Starting with easy stuff just because we want to make sure we can still do that even if it's x's and y's and z's. So let's take a look at this next example in number 2. 9x squared minus x over 3x plus 4 minus 3x squared minus 9x over 3x plus 4. So first of all, this is a subtraction problem, so we didn't do any of these last class. Is this an easy or a hard subtraction problem? Easy, for the same reason that that previous one was easy. These 2 denominators are exactly the same, right? The numerators we don't care about, it's the denominators. And they are both 3x plus 4, which means we can just go ahead and do our subtraction. So downstairs is a 3x plus 4. And then I'm just going to copy upstairs in the same way that the 2 and the 5 got copied upstairs here. So what's the first thing we're copying? 9x squared minus x. And then minus 3x squared minus 9x. Everyone agree? Right? It's just the same as the first fraction that we did with only numbers. And then we'll combine like terms. So what do we get for the x squareds? 6x squared, and then the x's minus 10x over 3x plus 4. Again, notice that denominator didn't change. It didn't become like a 6x plus 8, right? You don't add the denominators. You definitely don't subtract the denominators. That would give you a 0. You just copy the denominator. So far, so good. Okay, so one problem is that this is not the right answer. Anybody see the mistake that we made? What about the 3x squared? Yeah. Anybody see the mistake? This was a subtraction problem, right? I had one fraction subtract another fraction, which means that this entire thing was supposed to have been subtracted, yes? And so I'm going to throw parentheses around it. They aren't necessary, but I just want to kind of make it clear, that is a bag of stuff that is all being subtracted, right? Did we subtract the entire bag of stuff? Yeah, this minus 9x didn't get subtracted. We just copied it, but it didn't feel the effect of this subtraction sign. That's what it should have said. You need to subtract the entire bag of that second fraction. We see it? Just for symmetry, I'm going to throw parentheses around the first one too. That one doesn't matter, but it doesn't hurt to just put it everywhere. If you just put it everywhere, you'll get all the problems right. If you never put it, you'll get some of the problems wrong. Okay, so let's fix this. So I'm going to do my numerator all over again. I'm going to do this in 2 steps. I'm going to copy the first guy, 9x squared minus x, and then I'm going to distribute that minus sign. So it becomes minus 3x squared and then plus 9x. That's the issue right there. Okay, so go ahead and combine like terms and write down the correct answer. So what do we get here? 6x squared plus 8x over 3x plus 4. Fair? Any questions on that one? Okay, so that answer is correct, but before we say that it's the final answer, we have to make sure that our fraction is reduced or simplified. In the same way that you would never give me a final answer of 6 over 8, what would you say instead? You would say 3/4, right? You would never leave 6 over 8. We have to start looking at our new complicated fractions, the algebraic fractions. We have to look to simplify them every time before we put our final answer down. And the way that we simplified them was to cancel things that are the same or have common factors. So for example, can I cancel the 6 and the 3 and make a 2 and a 1? Why not? It is x squared and x, but that's not the part that makes it. It's not multiplication. This is a plus on the top. It is a plus on the bottom. The heart of last class was that you can only cancel when it's all multiplication, which means that we need to factor. So let's factor. Potentially it's the box. In this case, it's a different kind of factoring. I'm going to jump down here to this typed out version. What can you factor out on top? Greatest common factor on top? What comes out of both? 2 and an x, yeah? Okay. Fill in those blank parentheses, please. What's left? 2, 3x plus 4, right? And then I'll copy the bottom. All right, I see 3x plus 4 both places. Can I cancel those? You can. So I'm going to ask a question now. Why is it okay to cancel the bottom? The bottom is a plus. I thought we were only allowed to cancel when it was multiplication. Yeah, it's exactly the same. We're not really thinking of the bottom as an addition. We're thinking of the bottom as one complete thing, one whole. And so if we really wanted to, whoa, what happened? We really wanted to see that we could cancel, we could throw parentheses around it and put a 1 times. It's multiplication now, right? And so you don't have to get distracted that there's addition inside. It's fundamentally multiplication, and those two guys are exactly the same, so they cancel. So what's the simplified answer here? Just plain 2x. That's our answer. Any questions on that? So that's when we have addition or subtraction and like denominators, or the same denominators. It's a lot tougher when they're different denominators. Let's again tie into a problem that we know how to do. That is a problem with numbers in it. So let's look at part A here, number 4. 9 over 28 minus 3 over 40 minus 1 over 42. What makes this harder? We don't have a common denominator. And there's also 3 fractions there. Can you guys look at that and figure out what the lowest common denominator is? Is that easy or hard to tell what the LCD is? For me, it's hard. I can't just look at that and know immediately what the lowest common denominator is. Oftentimes, the ones that we get are so easy that we sort of get tricked into thinking it's like, oh, they're all easy. Let's make this 4 over 9, something like that. What number do 9 and 12 both go into? 3 goes into both of them, but I need something that they both go into. 72 works. Is there anything smaller than 72? 36. 36 is the lowest common denominator. And you can just do it by inspection when the numbers are small. But I can't for 28, 40, and 42. That's 3 numbers, and none of them is particularly small. So I'm going to show you a way that you can do this no matter how big the numbers are. And even though there's a lot of details here, I think that this is going to help us when we get to problems with x's, with variables in them. Okay, just like last class, the idea was to factor everything first. Here we're going to factor, but we only care about the denominators because we're only trying to build a common denominator. So 28 is going to get factored. It's 4 times 7. It's also 14 times 2. Which one do I want? Neither one. I want primes. I want you to factor all the way down. So do you buy that 28 is 2 times 2 times 7? And if you had to factor a number into primes, you could do that, right? 40, you can think of it as 4 times 10, and then factor those guys farther. But let's just make sure 2 times 2 times 2 times 5. What do you get? That's 40. Okay, and then 2 times 3 times 7? That's 42. So the denominators are exactly the same. They're just factored all the way to primes. What did I do with the numerators? Nothing, just plain copied them. Notice also that I've given us a lot of space here for some reason on my fractions, but right now they're equal to what they were before. Okay, so here's the key. We want a common denominator. We want these denominators to all be exactly the same when we're done. Let's just do the first 2 denominators. We'll come back to the third one. Let's look at the first 2 denominators. I see a 2 and a 2 in the first guy. How many 2's in the second guy? 3, which means this first guy needs another 2, yes? Okay, so I'm going to put down here times 2. Put it times 2. But I've cheated. You can't just randomly throw a times 2 someplace. How do I fix this? How do I do the opposite of the times 2 that I just put there? Is it 9 times 2 up there? Because you are allowed to multiply top and bottom by the same number, yes? Multiplying by 2 over 2 is just a fancy form of 1. And we know we can put that anywhere. Super. So I see a 2 and a 2 and a 2. I have 3 2's in both. They're getting closer to matching. What else is this first denominator missing? There's a 5. So let's put a 5. Times 5 on the bottom, and therefore times 5 on the top, right? Okay. So I think that the first denominator has everything it needs, but what is the second denominator missing that was in the first one? The 7. Let's give the second denominator a 7, and therefore a 7 on top. And the orders are different, but what can you say about those first 2 denominators? Aren't they the same? Don't worry about the numbers. Like, don't actually multiply them out, but just make sure that every single number matches. And they both have 3 2's and a 5 and a 7. Yes? So they're the same. Okay, now it's time to bring the third guy into the mix. Let's compare the first denominator to the last one. What is the first one missing that the last one has? 3, right? So let's give that first guy a 3, and then I think the first guy will be done. Times 3 times 3. That 9 is just sitting there, and it's going to be multiplied by everything that we just put up there. Was that the question, Will? Why do you want to put a 9 on the next fraction? Gotcha, gotcha. So the only things that we are trying to match are the denominators, and we're paying no attention to the numerators. It's just a common denominator we're trying to build. Okay. All right, so the first guy is good. What is the second guy missing from the last guy? Also a 3. Let's give that second guy a 3. Times 3 times 3. Okay, now it's time to bring the last guy into the mix. So what is the last guy missing from the, really either of these guys? Because I think that the middle two, the first and second denominators are the same again, right? They both just got another 3. So what is this guy, the last guy, missing? Let's see, so it's missing a 5. And it's missing how many 2's? 2 2's. So give this second guy 2 2's. And there's a lot of numbers floating around here, but if we just look very carefully, hopefully we'll see that the denominators match. I think they do. How many 2's do all the denominators have? They all have 3 2's. They all have a 3. They all have a 5. And they all have a 7. Yes? So they're the same. And guess what? Without even thinking about it, we have found the lowest common denominator. It is 2 times 2 times 7 times 2 times 5 times 3, which would have taken me an awful long time to just figure out by hand without doing this way. But whatever that number is, that's our LCD. I think this number is written out somewhere, maybe on the next page. Might be 840. But whatever it is, that's the lowest common denominator. Okay? All right, the next thing is to start crunching together the numbers on the top. So 9 times 2 times 5 times 3. We can use a calculator. This is written out on the next page, so we're not going to do much more writing, if any. But we multiply on top, and there's no need to do anything on the bottom. We're just going to leave the bottom in factored form. One thing to avoid is this temptation. Is it okay to cancel the 2's here? Is it legal or not legal? I know. Right. So that's why we shouldn't do it. But is it legal or not legal? These fractions are independent of each other. Is it okay to cancel those 2's? Yes, because it's all multiplication, right? But if you cancel the 2's, as Savannah says, you have just destroyed some of the work that you put in there. You don't have the same denominator anymore. So you'll always have this opportunity, and I just want to highlight, you never want to take it. You don't ever want to cancel the stuff that you just put in there. You put it there for a reason. It's totally okay to, like, I could just erase all of these things now, but then I'm back to the original problem, right? We put them all there so that we would have, come on back. Uh-oh, wait, uh-oh. There we go. Whew. So it's totally fine to, it's legal, but you're going the wrong way. All right, next page. Okay, so here's all the stuff written out that we just built. Then we actually do the multiplying. So you can see here I've got a 270 and a 63 and a 20. That's the multiplying on the top. And notice that I've just copied the subtraction symbols, right, to make it one problem, one fraction problem. And I've done all the arithmetic for you. It's 187. Super. That's on the top. Notice the bottom is still in factored form. Okay. And then technically we should verify that 187 over this guy doesn't have any common factors because we should reduce our fraction at the end. So I factored 187 for you. It turns out it's 11 times 17. So you tell me, looking at this guy, can we cancel any common factors? No, there aren't any. But if it had been, if we had decided to multiply all this through, we would have gotten 840. If you have 840, and 11 times 17 on the top, easy or hard to know if you can cancel? The top can't be reduced anymore. We've got primes on the top, but I don't know off the top of my head if 11 goes into 840, and I don't know if 17 goes into 840, which means 840 is not a good version of this number to be looking at. Way better was to leave it in factored form, right? If it's factored, then it's obvious whether or not you have common factors. So avoid the temptation to multiply out on the bottom. We're never going to be multiplying on the bottom. Okay. So that is how we do building an LCD with numbers. It's going to be exactly the same process with variables. We're going to jump down here to part B. All right, and I'm keeping an eye on the clock here. So this demo has still got a little bit left in it, and so it's just a little bit longer than our normal one. But like I said, there's no demo scheduled for Monday. So like once I finish doing my thing on these last two problems, you'll have the rest of today and then all of Monday to practice with these things. Okay, so here is a new problem. Same idea. There is a subtraction and an addition that tells me I need to build the lowest common denominator. So taking a look at these three denominators, the very first step when it was numbers was to factor, right? We turned all of the denominators into products of prime numbers, yes? And the word factor is the same word that we've been using here. So we are going to factor. What can you factor out of x squared plus 4x? X. And you're left with x plus 4. It's already written there. This guy, you can't factor anything out, so it's a box problem. Just to save us some time, I've written it out there. Can you factor 2x? Nope, it's already factored. It's good, so it's copied here. Everybody okay with the first step? Just like with numbers, factor the denominators first. Okay, and now we're going to build by putting in what's missing. Let's just look at the first two fractions. I see an x and an x plus 4. In the second fraction, x plus 4, x minus 3. What is the first fraction missing from that second fraction? X minus 3, so we put it down there, and therefore we also put it up there in parentheses now. In fact, I'm going to put everything in parentheses now. So go ahead and add that to top and bottom. I think the first fraction is good to go now. What is the second fraction missing that the first fraction has? Is x. So an x there and an x there. And I'm now forced to put in parentheses that weren't there before. Do you see where we need to add parentheses? That's right. Without those parentheses, it looks like the x is only hitting the minus 1. But the x is hitting the entire numerator. So all of a sudden, we need more grouping symbols that weren't there before. And while we're doing that, why don't we just group every numerator just kind of automatically? I'll put parentheses around that first 3. They're not necessary, but it's okay to put them. But we will need them around the 1 plus x, so might as well just put them everywhere. Okay, look at the first two denominators. What can you say? They're equal. Perfect, right? We got the same denominator. Now we're going to bring the third denominator into the fold. So I see a 2x. What is this first fraction missing? Is it missing 2x? It's missing just a 2, right? It's already got an x. So we don't need to stick another x in here. It's okay to stick another x in here, but it makes the problem much more complicated and potentially not reducible for us at the very end. It's not wrong, but we don't want to be adding stuff that isn't necessary. Could get to a place that we just can't get to the final answer from. I wouldn't, because I'm viewing this as two separate guys, 2 times x. Okay, all right, so my next thing here, so we said we were missing a times 2 and a times 2. So we'll put it in, times 2 on the bottom, times 2 on the top. I'm automatically throwing parentheses around everything that I put on top and bottom. Looking at the middle fraction, what is it missing from the last fraction? It's also a 2. In fact, it's going to be the same thing the first guy was missing because we built the first and second to be the same. Okay, so I think first two denominators are good. Now we got to get this third guy to match those first two. So what is the third guy missing from either of the first two? They're both the same at the moment. So what are we missing? X plus 4 and x minus 3, and the 2x that I see is already there. So x plus 4, x minus 3 are what we need to bring in on the last guy. Again, everything in parentheses. What can you say about those three denominators? They're what? They're all the same, yeah? Okay, so because they're all the same, we are ready to make one massive fraction with that denominator, right? So one copy of that denominator. You can copy it from any of your three denominators. The orders might be different, but they're all the same. So I'll just copy it from the first denominator, but it doesn't matter. They're all the same. And then I'm going to copy my numerators, separated by first a subtraction and then an addition. So lots of copying in this problem. First denominator and then subtract, right? Because that's subtract the second fraction. What's the next symbol after the second fraction? Addition. And then I'm copying here. Any questions on that step? What's the point of this? Well, it's just so fun. What does it do for you? Let's talk after class. Makes it so you don't have to take this course again. That's what it does for you. No, it's a good question. I don't mean to dismiss it. Algebraic fractions are not something that you will encounter in your everyday life, but it is sort of a natural place to go algebraically. You know lots of arithmetic of fractions. Now we're going to the next most complicated version of fractions, and it's this. And so it's just like relearning all of that. Yeah. All right. So I'm just going to skip to the answer key for this one because I think the rest of this is a fairly straightforward but a little bit time-consuming process that I don't want us to do together right now. But the next step is to distribute up on top. So distribute through all of these numerator things. This last guy is quite complicated, right? Because it's three binomials multiplied together. Do you feel like you could do that? Which just any part, or do you have a particular part? Yeah, let's do the first part. So just off on the side here. So in my mind, I would shuffle the 2 and the 3 together to make a 6, and then I would distribute that 6 through the parentheses. So this guy would become what? 6x minus 18. That's that step. It's more of the same for the other ones, but again, this last guy is quite complicated because you would first need to FOIL or distribute or lobster claw or monkey face, whatever you do, on maybe the first 2 parentheses, and then whatever you get, you would then distribute onto the x minus 3. So I'm just going to skip to the answer, which is on the next page. There's the 6x minus 18 that we just built. There's the distributing we didn't do. There's the complicated one that we didn't do. And then we've got like terms up here, don't we? Right, I can maybe get rid of all these parentheses. The 6x minus 18 gets copied, but that subtraction sign changes everything in the middle parentheses. Yeah? So it becomes minus 10x squared and then plus 2x. That is there, right? And then the whole idea of all that is that finally we have some like terms. So for example, there's a 6x and a positive 2x and a minus 11x. Altogether, what is that? 6x plus 2x minus 11x is negative 3x. And that's there. So you do all of that for the purposes of getting to this place where you can combine like terms. Notice that the denominator did not get multiplied out. There's no reason to ever multiply out on that denominator. Upstairs, yes, because you can combine like terms. But downstairs, if you multiply that out, all it's going to do is get bigger. And there aren't going to be any like terms to combine. It's just going to be one bigger thing. Any questions on this? This is our final answer there. Yeah. Great. All right, let's go back and we'll do one more example. These ones are tough, aren't they? It's pretty involved. So So this is just me speaking personally, not like a departmental philosophy, but I love having this be like the last topic because it's really hard and you guys are like so tired and beaten down that you can't fight back at this point in the semester. Like I can just throw this like crazy complicated thing, although Alex still has some energy apparently. Must be those caffeine drinks. All right, last example. Just the highlights on this one. Here is the original problem. It's just two fractions, 4 over x squared minus x, subtract x minus 7 over this complicated thing. First step is to factor. What can you factor out of x squared minus x? X comes out, left with 1 minus x there. So far, so good. This thing in the first parentheses, x squared plus 4x minus 5. That's a box problem. Not going to show the highlights, just going to show the answer. That guy, when you do the box, turns into that product right there. All right? The only reason this is slightly different, it's not even different, but the only reason I'm highlighting this example is that what do you see in that second denominator? That's in the first denominator. What about the second denominator? There are 3 of those guys, and 2 of them are exactly the same, right? There's x minus 1 twice, so I just want to make sure we can handle it. So looking at this first fraction, what is it missing that the second guy has? It's missing the x plus 5, definitely, so I'm going to throw that in there. Yeah, and that's the key. It's also missing an x minus 1. It has a single x minus 1. It needed 2 x minus 1s. So we just give it another one. Right? And now it has x minus 1, x minus 1. It does. Okay, and then the last guy is pretty straightforward. What is it missing? Just a single x, just a single x. And that means, just like before, we need to introduce parentheses, even though they didn't have to be there before. And I'm going to stop this problem there because the rest of it is the same. The only piece I wanted to highlight here was how do you handle when it's repeated factors? Well, you just give the repeated factors. Any questions on that one? Okay, so the activity starts 2 pages away. And I will tell you that this activity is long, and the demo is a little bit long, so we've got, how long? 38 minutes? So that may or may not be enough time. It depends on how quickly you guys can motor through the activity and even more practice. Raise a flag if I can help.